Episode 161 of CppCast with guest Simon Brand, recorded July 26, 2018. This episode of CppCast is sponsored by Backtrace, the turnkey debugging platform that helps you spend less time debugging and more time building. Get to the root cause quickly with detailed information at your fingertips. Start your free trial at backtrace.io/CppCast. In this episode, we discuss undefined behavior and Qt Creator updates. Then we talk to Simon Brand. Simon gives us a preview of his upcoming CppCon talks and much more. Welcome to episode 161 of CppCast, the first podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm right, Rob. How are you doing?
I'm doing okay. You know, every week I post the episodes to the CPP subreddit, and for the first time ever, someone golded one of those submissions. I've never had Reddit Gold before.
Which one was it for, if I might ask?
I believe it was for the episode with Dimitri.
Interesting.
Yeah. So thank you to the kind listener who gave me some Reddit Gold.
You know, I have absolutely no idea what that actually means.
No one does. No one does.
No, okay.
Apparently it turns off ads when you're logged in, so that's kind of nice.
Oh, I thought that's what the ad block was for.
Yeah, well, that's how every episode I like to read a piece of feedback. This week we got an email from Darstar. He wrote, "Hi, first/zeroth of all, thank you for producing content I enjoy. So is CppCast the first or the 0th podcast for C++ developers by C++ developers? Thanks again." I think of those as the same thing, you know?
Yeah,
I agree that 0th indexing is very important. I hate programming languages that use 1 as the first array element, but I think of first and 0th kind of as an interchangeable thing as a programmer.
That's, it's interesting. You know, I would be on board with changing the intro so that we say we're the 0th podcast. However, it sounds a little bit like we're saying that we're zeros, which isn't generally a good content.
No. So I think we'll stick with first, although we're both proponents of 0-based indexing in programming, right?
Yeah, I think we'll stick with first, yeah.
Okay. Well, we'd love to hear your thoughts about the show as well. You can always reach out to us on Facebook, Twitter, or email us at feedback@cppcast.com, and don't forget to leave us a review on iTunes. Joining us today is Simon Brand. Simon is a GPU toolchain developer at CodePlay Software in Edinburgh. He turns into a metaprogramming fiend every full moon when he can be found bringing compilers to their knees with template errors and debating undefined behavior on the C++ Slack channel. He co-organizes the Edinburgh C++ user group and contributes to various programming standards bodies. Outside of programming, he enjoys experimental films, homebrewing, and board games. Simon, welcome back to the show.
Hi, thanks very much.
All right, so recent homebrewing endeavors?
Not as recent as I would like, although I did just get 60 swing cap bottles for free from a local pub, and they're the proper good swing cap bottles.
That's not cheap, right?
Yeah, that would set you back like a good £60. I guess that's like $90 at this stage or something.
Right. Wow, yeah, that's a pretty good find.
No plans what you're going to put into those yet?
I think I might do an IPA or something soon, probably a double IPA. We've got the weather for it in Scotland at the moment, so...
Sounds good.
Yeah, it's like hot there, right?
Yeah, it's Scotland's idea of a heat wave, which is like 25 degrees Celsius.
Wait a minute, now that's really not that hot.
Yeah, it's still enough to like knock everyone out here if we're not used to this.
I'm having to make sure I have my conversion here. Yeah, that's 77, Rob.
Yeah. It's like 90 to 100 every day here where I am.
Yeah.
Okay, well, Simon, we got a couple news articles to discuss. Feel free to comment on any of these, and then we'll start talking to you more about your CppCon talks. You got an exciting year coming up at the conference, right?
Yep.
Okay. Well, the first one we have, speaking of undefined behavior, is this article from Chris Whellen's The Value of Undefined Behavior. Jason, you want to introduce this one?
Yeah, he goes through like basically why we want undefined behavior in the language effectively, and how there's things that the compiler can optimize and whatever. And the more we define, the less room there is for some of this. But
and one thing you pointed out that part of it is to make things easier for implementers, which I'm not sure if I was aware of.
well, yeah, and part of it is if you overspecify the language, then you make it almost impossible to run C++ on certain types of hardware or whatever.
Right.
Yeah, or they might have to introduce additional checks or extra instructions to make sure that they're conforming to what the standard says, even though like their default behavior might be okay.
Right. So yeah, definitely an interesting article. We're always talking about how to avoid undefined behavior, but it's interesting reading these articles talking about the occasional benefits of it.
Yeah, I've had conversations with people, and I don't think it's come up on the podcast, but I could be wrong. The notion of making a compiler that intentionally is malevolent, I guess, in the face of undefined behavior, just to like punish you for using undefined behavior. It could be a fun experiment, I guess, but no one's doing that I'm aware of.
That would be interesting, yeah. Okay.
I have thought about.
Go ahead.
I have thought about doing something like that, like just modifying Clang so that some check actually does delete your hard drive or something.
That would be great. Calls your, I don't know, family members that you haven't talked to in a while or something.
Yeah.
Okay, next one we have is Qt Creator 4.7 was released, and I guess the big change here is that they are officially switching over to using Clang instead of their own internal C++ model.
Yes, that did seem to be the big item.
Yeah.
It seems like a good move. It makes it a lot easier for them to work with the new versions of the standard and new features which are coming in, because there's so much stuff now getting into C++ that must be hard for all of these individual tools to keep up, so kind of centralizing it somewhat seems like a good idea.
Okay, so at the risk of maybe playing devil's advocate here or something, do we think that... So Clang is very, very good about sticking to the C++ standard. I will preface with that. But do we think we're at a risk of, like, whatever Clang it does implement becoming, like, the de facto dialect of C++ because we're using these tools in so many places now?
I guess it's like, what features or what areas would we be relying on the implementation-defined behavior of Clang? Like, are there any very important parts which would be doing that? Especially when we're mostly thinking about these tools and static analysis and things like that, rather than a lot of these tools aren't so much focused on the dynamic behavior. It's mostly about diagnosis and giving you information about your types and things like that. So I can't think off the top of my head big issues which would be relying on for things like that.
The only thing I can think that might plausibly come up is Clang does strictly evaluate parameters left to right, and neither GCC or MSVC do.
Yeah, I don't know. It doesn't seem like it's a huge concern for the community to be kind of rallying around a certain tool this way.
Yeah. I just thought I'd ask.
In my experience, C++ programmers are very quick to point out if, actually this thing is implementation defined, or you're relying on some aspect of this compiler. We're, as a community, we're not very shy about pointing these things out, in my experience.
Right.
It's very true. Okay, and then the last article we have today, also Qt related. This is the Qt and coroutines TS. And, interesting example. I think we've talked before about signals and slots being a really common way of hooking up your Qt events. And this is an example of how you could do this using coroutines, and it is much, much cleaner, to just say await for some click event and do this. And once you have done that twice, you can go about your business instead of having to track a bunch of state within your slot event handlers.
Yeah, I thought this would be an interesting one to cover because I feel like with all the conversation about coroutines, for myself personally, I'm like, I just don't really know how this would affect my real world code. Mm-hmm. And I know you have more experience with coroutine-like things because of your C# experience, Rob, but I don't. I've spent a lot of time in the C++ world.
Yeah, this is not really a pattern I've seen too much in C# with kind of making a task await on an event, but it's something I might try out. See how well it works in C#.
That'd be cool.
Well it might work in coroutines. How about you, Simon?
Yeah. I really like this approach. So much of like asynchronous programming or this kind of event-driven programming, the actual control flow and kind of trying to trace everything that's happening becomes kind of inside out, and this puts it back into the right order, so it looks like straight line code, and all of the actual event-driven stuff is just kind of hidden underneath the covers. So yeah, it's very nice.
Yeah.
Okay, well, Simon, as we mentioned before, you're going to be at CppCon again this year, and you signed up to do 4 talks, is that right?
Yeah, this is actually my first year at CppCon,
okay.
So I'm starting easily.
Well, you've spoken multiple times at Meeting C++, right?
I gave 2 talks at Meeting C++, but only been there once.
Okay, 2 talks in the same year. Any other conferences, your local users group you're involved with?
Yeah, users group. I spoke at C++ Russia this year and Embo++ as well.
Right. Oh, okay. Oh, yeah. So you're highly experienced at this point. All right. So what was the motivation for submitting 4 talks? Let's start there.
Yeah, well, it was the kind of thing where it was the first time when I'd submitted to CppCon, and I really wanted to go. So it's like, well, if I submit 2 talks, then I've got a fairly good chance of getting in. I was like, and it's the kind of thing, you're thinking, oh, what if 2 talks isn't enough? Maybe I should submit a 3rd one. And then in trying to come up with a 3rd one, I was like, oh, I have another idea as well. So I ended up just submitting 4 talks. And I was just like, this will be fine as long as all 4 talks aren't accepted. And then, of course, all 4 talks are accepted.
So are they all fresh ideas or anything that you've presented previously?
One of them is one that I gave at Meeting C++. The others are all new, although that some of them are based off of blog posts I've done and things like that.
Okay.
Did you consider asking John Kolb and the CppCon committee, like, hey, could I maybe back out of 1 or 2 of these?
Yeah, I did think about it, but then I also thought it would be a interesting challenge and not one which I'd have many opportunities to try again. Like, even in the future, if I submit 4 talks again, the chances of all 4 of them getting accepted again would probably be quite low. So I thought I may as well give it a try and see how it goes.
Well, if these 4 go well, then in the future, the next 4 have a higher probability of getting accepted, just for the record.
What have I signed myself up to?
I think since I've been speaking at conferences for a few years now, I would like to point out for our listeners who are thinking, hey, I thought about submitting a talk to a conference, but I'm never going to do that because I don't want to get stuck in this world of doing, 20 talks. You are a volunteer at the conference, effectively. You are allowed to back out of talks. So there's no way that they can require you to do all these talks. And John, might be quietly disagreeing when he's listening to this or something. But just for the record, so don't take Simon's experience and be afraid to submit talks in the future. to our other listeners. Okay. Now that that's out of the way, let's talk about what your talks actually are.
Sure. So, as I said, one of them is one I gave at Meeting C++ last year. So that's the How C++ Debuggers Work talk.
Okay.
So it's all about... so I did a lot of work on debuggers in the first few years I was at CodePlay. And there are very few resources about how debuggers actually work online and how you might write one. So I wrote a 10-part blog post series, and we talked about this last time I was on, about a year ago, and then gave the talk at Meeting C++, which was kind of just putting a lot of that stuff into talk form. Not so much like how do you write one, but how does it all work? And so this is going to be essentially the same as Meeting C++, but I'm going to... that one was a little bit more generic. Like it could have applied to pretty much any native debugger. For this version, I'm going to try and make it a bit more C++ focused, to talk about how templates interact with debuggers, how name mangling is actually exposed in the debug information, things like that. It might also be interesting to look at how debuggers would interact with things like contracts or coroutines even.
That could definitely be interesting.
Yeah, because I'm not sure how much like debugger support was actually considered or discussed during the standardization for these features. So it would be interesting to at least consider.
Okay, so is it the same session length, 1 hour at
Meeting C++? 1 hour session. Yep.
Okay. So new material. So if someone saw your Meeting C++ session, should they come to your CppCon session?
Yeah, I'm going to try and make it as... it'll be expanded. I'm going to try and tighten up some bits, make it more of a kind of story of... because the Meeting C++ one was like, okay, here's a debugger feature, here's how it works, here's another debugger feature, here's how it works, and so on and so forth. So I thought it would be better to be like, okay, say I have this problem, and I'm going to go through a bunch of debugger features which will actually help me solve this problem. And here's how all of these work, and try and kind of draw more of a nice path through all the features rather than just chunking them up and describing them one by one.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Backtrace is a debugging platform that improves software quality, reliability, and support by bringing deep introspection and automation throughout the software error lifecycle. Spend less time debugging and reduce your mean time to resolution by using the first and only platform to combine symbolic debugging, error aggregation, and state analysis. At the time of error, Backtrace jumps into action, capturing detailed dumps of application and environmental state. Backtrace then performs automated analysis on process memory and executable code to classify errors and highlight important signals such as heap corruption, malware, and much more. This data is aggregated and archived in a centralized object store, providing your team a single system to investigate errors across your environments. Join industry leaders like Fastly, Message Systems, and AppNexus that use Backtrace to modernize their debugging infrastructure. It's free to try, minutes to set up, fully featured with no commitment necessary. Check them out at backtrace.io/CppCast. Okay, so your first talk is on debuggers. What is going to be the second one?
So another talk is how to write well-behaved value wrappers. So this is based a lot on my implementations of std expected and optional, but it just as equally applies to things like tuple and variant and pair and pretty much anything which is a kind of generic type which wants to act like a value and expose behavior which is consistent with the values it's wrapping. So the talk's going to go over a bunch of techniques for making these types behave well and to be performant, because there are things like trivial copyability, which you have to actually work a little bit hard to expose properly in the value wrapper. So for example, the original version of libstd C++'s optional did not propagate the trivially copyability of the underlying object. So if you were passing these over function boundaries, like as arguments or return values, then if you're using like the sysv ABI, then they're going to be passed on the stack, just because that's how the ABI is specified. So if you want it to be passed in registers, like if this is just an optional int, you want that to be passed in registers. So you have to make sure that the type is trivially copyable. So there are techniques you can use to do that, like inherit from some private base class, which conditionally defines or defaults those special member functions. And it gets a little bit hairy and is kind of non-obvious when you're first looking at it. But it does actually work.
I found that an interesting exercise in trying to maintain trivial destructibility on the same kind of...
Yeah, I talk about that as well. It's very much the same kind of issue. The same goes with propagating the deletion of special member functions. And I'll talk about things like ref-qualified member functions for propagating the value category of the object you're calling something on. And for all of these things, I'll also be looking at how current proposals or things which are coming in C++20 might help make this a little bit easier, because currently a lot of these techniques are a little bit esoteric, and there are a lot of new features like the spaceship operator for comparisons and concepts, and maybe deducing this, which would help massively in a lot of these things. So I'll kind of look at the performance aspects and look at some assembly code and look at the future and try and explore lots of different avenues within this kind of niche.
All right, so I am slightly confused by the name value types, because in my head, when you started to say that, I'm thinking of like strongly typed value wrappers, like Jonathan Mueller likes to blog about and stuff, I think, where you're talking like it's something that wraps an int and then you have all of your normal operations on it, but it gives you a strongly typed wrapper. And so if I'm understanding correctly, you're not talking about that kind of thing.
Well, even for that kind of thing, some of these concepts still apply. Like, you still want to expose all of the like comparison operators and things like that, and I'll talk about those. And so there are still aspects which will apply to this kind of strong types kind of style as well. Okay.
Now, I am curious also for actually demonstrating these techniques. Finding a compiler right now that implements the spaceship operator and concepts and some of the other things you've talked about. Not trivial.
Yeah, so the assembly stuff will mostly be looking at like what happens if you don't do this. So if you don't correctly propagate trivial destructibility, like you mentioned, and then you have a vector of these things, then the code generated for the destruction of the vector is pretty big. But if you propagate it properly, then it becomes essentially a no-op. So I'll kind of compare and contrast. Here's why you should do this thing, because it impacts the performance, and you can actually see how it impacts the performance by looking at the assembly. And maybe I'll have some like quick benchmarks or something as well.
Okay. And how about one of the other ones?
So one of them is going to be a half session, so a 30-minute talk about...
You should have backed out of the other three and just kept the 30-minute. Just kidding.
And that one's going to be about how function overloading and function templates interact with higher-order functions, and how there's kind of a fundamental hole in support for these things in C++ at the moment. So like if you have a high-order function, just like anything in the algorithm header, and you try and pass a function template to it, then you can't just pass the name. You have to like explicitly choose a specialization, or you have to wrap it up in a lambda. It's the same for overloading. Like you have to static cast it or wrap it up in a lambda again. or make like a what do they call them? The customization point objects, like the ranges style things, which just hide everything in an explicitly defined function object. And if you don't do any of these things, then you get compiler errors, and if you do these things, then your code looks ugly. So I'm going to explore some techniques for doing it now, just like defining a macro which builds a lambda for you, which correctly perfect for as arguments, and propagates no accept, and is SVNA friendly, and all of these things. And because you don't want to be doing that by hand every single time you want to call a high order function. And then I'll look at some approaches which the standard could take to make this easier. So there were a few proposals which have been discussed at recent meetings, but unfortunately got rejected. And then there's one which is currently being written, and we'll see how that goes. But yes, I'm going to look at the current state of things, which is bad, really bad, and look at how we might try and fix it.
I'm curious if you know if any of these proposals tie into any of the things that have been talked about for reflection. But I mean, can you reflect on a template function or a function template since a function template doesn't actually exist? Really?
Yeah, I don't think I've actually looked at that. That might be an interesting avenue to consider. Yeah, because I guess I guess it would have a similar issue unless it Reflexper it's called, unless it had like explicit support for overload sets given a name, then you would have a similar issue where if you're wanting to reflect on something, you have to say exactly what you're wanting to reflect on.
Right. So I am curious, though, if you can give us a preview as to how any of these proposals that you are already planning to talk about would work in this kind of situation. Yeah,
so the one which is currently still being written, it hasn't been posted in the mailings yet, but the author said I could mention it here. So Barry Revson and Andrew Sutton are working on a proposal for std overload set. So the idea is this is a kind of magic type, and you can pass it a name and it will deduce a type which essentially wraps all of these overloads or function template specializations up into one object which you can pass around. And so the idea is that the preferred way of using this would be by sticking it in the actual function interface for the higher order function, so that when you pass a name as the function argument, then it gets deduced and you don't have to write any additional magic at the call site. But if you have a function which does not have a std overload set overload, then you could construct one automatically and just pass it through. And if the higher order function takes like a std function or just a deduced template parameter, then it should still work.
This, and to make sure I'm clear on this would truly be magic. It would be impossible to implement this as a library function today.
Yeah, absolutely. It'd have to have compiler support.
Okay. Yeah. It also sounds like it could be handy for creating visitors.
Yeah, I guess it would be. Yeah, because you'd have exactly the same problem if you have an overload set which you want to pass as a visitor, then you'd have to wrap it up in the lambda. So yeah, it would definitely go to solving that issue.
Yeah.
Yeah, because there'd been a few proposals to solve the same issue before. One of which Andrew Sutton wrote, and it was like a kind of if we think we can make this call work, then the compiler will just work out what needs to be done, and it'll all be done under the hood without the programmer having to do anything. And it turned out that there were some kind of fundamental issues with that. And then Mikhail Domniak, I don't know how to pronounce his name, but
I think it's close.
Yeah. he had a proposal for a lift operator, which is just like a open square brace, close square brace, which you put before a name, and that would essentially lift that name into an overload set. So it was doing something kind of similar to the std overload set, but with some special syntax, and it wasn't something that you could put in a function interface.
So what is the actual result of this? Is it a function object? Is it a Lambda kind of thing, like something we can reason about, or is it something we're not allowed to know about?
So I think currently it kind of depends on what you are passing. So if you like just create a std overload set out of a function pointer, then I think I'd have to check again, but I think that would just result in a function pointer.
That would make sense. No reason to add any overhead.
Yeah,
if not
exactly.
necessary.
But if you pass the name of an overloaded function, then it would have to lift it into a Lambda type thing.
Okay. That sounds pretty cool.
Yeah. And is there one more talk we haven't talked about yet?
Yes. So this one, what did we end up calling it? It's a joint talk that I'm giving with Phil Nash, and we're going to.
It's harder to back out of the joint ones.
Yes. Yeah. Exactly. But it's going to be on error handling in C++. So it's going to focus a lot on. It's going to go all the way from like error codes to exceptions through to std expected and into the static exceptions proposal which Herb Sutter has written. It's called "What Could Possibly Go Wrong." So yeah, we're going to be evaluating a lot of these different approaches, and it's going to be quite similar to I don't know if you've seen Phil Nash's talks. He gave one at C++ Now entitled "Optional is Not a Failure."
Yes.
So it's going to be quite similar to that. There's a few extra things which we want to cover in this talk, which will replace some of the content for that one. But it's going to be kind of a similar style, just evaluating different approaches. One of the things which I want to talk about is... So, did both of you read the static exceptions proposal?
Yes, I did.
Yeah, it's been a while, but yes.
So maybe I could summarize it for listeners who haven't read it. So the idea is that the current C++ exceptions model is kind of against the core C++ principle of you don't pay for what you don't use, and that if you enable exceptions, then extra code is going to be generated in order to actually make sure that the rules in the standard are followed for how these things are propagated and caught and things like that. So if you just enable them, then you're paying for something. And even if you're using them and you actually want exceptions and you want to throw them and you want to catch them, then there's still overhead associated, because you can throw an object of any type and that might get caught immediately, or it might get caught way back up the call stack. So the compiler has to do a lot of work and add a lot of extra instrumentation into your code in order to make sure that this all works, no matter what type you throw and no matter how far up the call stack it's propagated. So the idea of the static exceptions proposal is that you say, I'm a function and I could produce an exception and it will be of this type. So you statically know what type you're going to be throwing. And that means that not only do you know the size of the type, so you don't need to dynamically allocate these things, but you can also just return it as if you were returning a normal return value. So it kind of translates your function for if I have a function which returns an int, and I say I can throw an object of type std error, which will be a special thing, then it kind of translates your function into something which returns either an int or a std error. So it's kind of like std expected, but built into the language.
Right.
So
Okay.
that's the kind of overview of how it works. And in the proposal, there's a bunch of optional stuff, which is kind of related to the proposal and would augment it somewhat, but isn't part of the kind of core functionality. So there's things like operator try, which Niall Douglas had a standalone proposal for as well. But the idea of operator try is you put it before a call to some function which could throw, and then if it does throw, then you essentially early exit, and it lets you write all this stuff in a straight line, kind of like coroutines in a lot of ways. You're not having to pepper about a lot of additional boilerplate. You're kind of just propagating things as you get them. But the thing which I think is really interesting about having to like manually specify that I want to propagate this error backwards is that if you don't do that, you get a compiler error. So if I call a function which could throw, and I don't put a try before it, then the compiler is going to tell me that I've forgotten something, which means that I need to program more defensively. I need to always be thinking about, okay, well, I'm going to call this function, and I need to think about what I do in the error case. Maybe that's just I propagate the error back up to call stack. Maybe it's I do some manual handling, but I always have to write some code in order to handle it, even if it's just writing try before the call. So I think that's a really interesting element to the whole discussion, especially because I did some programming in Rust, and writing a parser in Rust, I was always thinking about those edge cases of, okay, well, I'm at this point in parsing, and I get some unexpected token. How am I going to deal with that? And I was always thinking about how this is going to work. So when I actually got kind of a finished parser, it was very robust because I thought about all the edge cases. Whereas with C++, it's a little bit, well, actually it's a lot easier to just kind of say, okay, well, I'll program for the common case, and oh yeah, if this error could happen, so I'll fix it here, and oh, this error could happen, but you're not forced by your compiler to think about these things. So I think that's quite valuable.
That's kind of... I'm cautiously optimistic about that aspect of it, because having used Java back in the early days and having to always account for all the different types of exceptions that could happen, and either try and catch or repropagate, and now I'm assuming this isn't going to try to change the rules again where we have to explicitly specify all of the different types of exceptions that could possibly happen or something like in the Java land.
Yes, I mean, you're with the static exceptions, you can only throw one type of error.
Okay.
And that might be an error code which like aggregates a lot of possible runtime errors. So it could be a type which at runtime could say, oh, I ran out of memory, or file not found, or any of these kind of system level errors. Or I guess like if you had multiple errors which could occur, you could throw something like a std variant, I guess.
Yeah.
I'm not sure if that's the best option, but then you end up like visiting on something you catch. Yeah, it might work, but
Should work.
So you said you were involved in the standards committees. Did you attend Rapperswell?
no, so the C++ standard stuff I haven't done a whole lot of work for. I've written a handful of proposals and co-authored a few of them. Most of my standards work was on HSA, which is a heterogeneous heterogeneous systems architecture. It was like a very low level hardware description and intermediate representation and runtime for heterogeneous systems, like if you have a CPU and a GPU and DSP and some other accelerators. So it's something which was pushed mostly by AMD and Qualcomm, Samsung, ARM, people like this. So that's where I did most of my standard stuff.
Okay.
But yeah, I have a couple of papers which are going through the standards at the moment. One of which is adding monadic extensions to std optional.
So what does that mean?
Yeah, I guess I used the M word, didn't I? So.
You used the M word. Now you have to explain exactly what a monad is on air. You're legally required to do that.
Well, arrest me because I'm not going to do that. But I will explain what it means for optional because that's a lot more useful to everyone, I think. So what it essentially means is if you're using std optional in its current state, and you have a lot of operations which will return an optional, then you would essentially have to do something like call a function, check if it failed, call the next function, check if that failed, call the next function, check if that one failed, for some definition of failure, but you know what I mean. So essentially all of your business logic is interrupted by you having to handle this context of whether I got a value or not. And that's not great. You end up trying to read this code. It's not obvious what the intention is because there's so many checks. So what you really want is something like, say, okay, I have this pipeline of operations which I want to execute on this data. If at any point any of these fail, or like if at any point any of these don't return a value, then I just want to exit out and not do the rest of the pipeline. And that's what the kind of monadic style of programming gives you. You push the handling of the context into the implementation of the type rather than having to do it manually. That's the kind of essence of it.
So what does this actually look like? Is it like a .then kind of thing? Or?
Yeah, essentially. So the proposal has 3 member functions which it adds to optional. One of them is map, where you take the value out of the optional, if there is one, you apply some transformation, and then you put it back into an optional. But if there wasn't value, then you just do nothing. It's a no-op.
Okay.
So that's map. It's kind of like a std transform, essentially. Like, if you have a empty vector and you do a std transform on it, then you do nothing. If you have a vector with one element, then you're going to take that element, call a function, and put it back in a vector. It's essentially the same thing. So that's one member function. The next one is and then, which is similar, but is for composing operations which themselves return optionals. So this is the kind of case where you have a bunch of operations which themselves could produce no value, and you want to push all of that context aside. So you just say, I want to do this, and this, and this, and this, and this, and if at any point one of those returns null-opt, then the whole expression just stops evaluating those additional calls. I mean, the calls are evaluated, but like the function you pass isn't called.
Okay.
And the final one is or else, which is just, if there is no value stored, then do this thing. And that's quite useful for if you have an interface which uses exceptions, then you can use this to kind of to get out of your monadic style of programming and into exceptions land. So you could say something like, do these operations or else throw an exception. So you can kind of your implementation could be done in this monadic style, and your interface could still be specified using dynamic exceptions.
So if you have this like chain of if then, or what else? Whatever it was called, and then it fails halfway through, do you get any way of knowing where it failed?
Not with optional. With expected, because for people who don't know, expected is essentially, it's like optional, but it gives you a a kind of error value. So either I have the value requested, or I have something which tells you why I didn't get the value. So expected would give you that additional information. With optional, you would just know that I didn't get a value at some point in this pipeline. And maybe that's okay for your domain, maybe it's not, and you use expected instead. And expected is going to make it into C++ 20, hopefully.
Right.
But it's also implementable previously, so I have a version on my GitHub which is usable in C++ 11.
So, with these 4 talks, debuggers, value types, higher order functions, and error handling, are you hoping to give them in a particular order? Are we going to see like a common thread through any of them? Will one refer back to another? I can see some places where you might do this.
Yeah, so the one on value types and the one on error handling kind of interact a bit, because a lot of the error handling facilities, which we'll talk about, when you're implementing them, you have to think about a lot of these concerns. And the overloading one will also play into that a bit, because if you have something like a monadic interface or something with higher order functions, then you need to think about these considerations. So those 3 talks are kind of related, and then the debugger one is off to the side a bit. I probably won't tie them together too much, because I doubt many people will want to go to all 4 of my talks. You probably get enough of me after the first 1 or 2. But yeah.
Well, that's what the online recordings are for afterwards.
Yes.
Yeah. Okay, well, it's been great having you on the show again today, Simon. Is there anything else you want to talk about before we let you go?
I guess we could briefly talk about, since last year, I've also been involved in setting up the Hash Include community, which is a diversity community and initiative for C++ programmers. So trying to get... we have a Discord server which has a public invitation, so people can jump on there and just come and talk about C++ and how we can kind of improve our spaces to be more welcoming and inclusive of minority groups and people who aren't so well represented in C++ communities.
And how's the effort going so far?
Yeah, I mean, we've got, I think we hit maybe 400 people on our Discord just the other day.
Oh, wow.
So that's been cool, and we're discussing ways in which we can have a presence at conferences and help people out, and maybe run some events, like we're talking about maybe running some mock interviews or something. So if you're a junior programmer and you don't have much experience in interviewing situations, then you could sit down with someone and try it out and get some feedback on how you interview, and it's not so much of a high stakes environment. So we thought that might help people.
That does sound like that could be very helpful for a lot of people, actually.
Yeah. Okay, well, it's been great having you on the show again today, Simon.
Yeah, thanks very much for having me.
Thanks for coming.
Thanks so much for listening in as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in. Or if you have a suggestion for a topic, I'd love to hear about that too. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you like CppCast on Facebook and follow CppCast on Twitter. You can also follow me at Rob W. Irving and Jason at LeftKiss on Twitter. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. Website at CppCast.com. Theme music for this episode is provided by podcastthemes.com.